Human activities influence the biodiversity both directly and indirectly. In recent times, these anthropogenic activities has increased the rate of extinction dramatically. In this video, I am going to talk about how these extinction rates are estimated and how human activities are influencing the extinction rate. Estimating the extinction rate is a bit difficult. Scientists used to estimate past, present, and future rates of extinction. Current rate of extinction is like the cataloging the extinction, how the organism is performing, and how is there a chance of this organism to get extincted. Things like that is considered in the current extinction or catalog extinctions. So scientists also estimate the past rate of extinction based on the fossil records and everything, how organisms got extincted in history, and based on the current and the past extinction rate, they are able to project the future extinction rates. So estimation of extinction rates including the cataloging, past and future extinction rate estimation. There are several reasons why the estimation of extinction rate is a bit difficult. Firstly, extinction takes long time, especially when we are comparing it with the human lifetime. Our Earth is like 5 billion years old, and life on Earth is 3.5 billion years old. Human population itself is about 1 million years old, that's 10 lakh years old. And extinction usually take maybe 1000 or 10,000 years to happen. So the time frame is so high when compared to a lifetime of a human, like maybe 70 to 80 years. So it's very difficult to predict and study the rates of extinction. Secondly, there are large number of organisms living in our Earth. We are estimated to have 10 million organisms. To study the habitat, ecological roles, and the possibilities of extinction of this whole organism is a bit difficult. And finally, each organisms play a complex ecological roles. And we don't know about the ecological roles of these 10 million organisms currently living on this earth. And we don't know what happens if one organism gets extincted. What happens to the second, another organism same in the same habitat, or whether it is going to affect it positively or negatively. We don't really have any idea. And in some cases, like we think some organism is got extincted, but after maybe 50 or 100 years, they got reappear. So things like that also appears. We maybe, as per our records, or we didn't see this organism for a prolonged time, and no one has documented its presence, and we document it as extinction of that organism. But after many years or many time, it reappears in same habitat or in a different habitat. Those are called the Lazarus taxa. It also happens in the fossil records. Maybe we have seen this fossils of this organism for a particular duration and got extincted, like it is not seen in the related time periods, but it got reappears again. So things like that also occurs when we are estimating the extinction rate. And typically a species on earth lives for 4 million years. If you want to put it in range, 1 to 10 million years. So typically its average is 4 million years, but it's somewhere between 1 to 10 million years. And there are different methods to estimating the extinction rates. Firstly, the fossil records. We'll examine the fossil records so that we will get an idea about how the extinction has occurred in the past. And we can actually project these extinction rates, basically the background extinction rates and the mass extinctions, to future. Secondly, we have the molecular clock. Molecular clock is nothing but the changes in the DNA. We know this DNA is made up of 4 different base pairs and everything, and there is a chance of or the process of natural mutation to this DNA, and it occurs in very low rate and very constantly. So depending on the changes in number of changes in a particular segment of DNA, we can actually calculate the time duration or the rates of speciation and things like that. Or if we get a fossil and we got the DNA, we can actually track how old this fossil was, or how old, how much long it has lived. Things like that can be calculated by comparing the changes in DNA. So that's what's the molecular clocks. Then we have species area relationship. That's simply the number of species present increases with the size of an area. If the area is high, the habitable area is high, the number of species will increase, the biodiversity will increase. If a habitable areas go and shrink, what happens is the number of species, the diversity will reduce. That's a simple relationship between the species diversity and the area. And scientists use this model to estimate the number of current and future extinction. It's called a island model actually, and we can actually see if we have a habitat an organism, if it is surrounded by some degrading habitats, and or the human colonization or agriculture purpose, if the habitat is going to shrink and shrink, we can actually expect a loss in biodiversity and a loss in the increase in the extinction rates. If another habitat is enriched and it is expanding, if it is expanding, the species diversity is going to increase. So there is a direct relationship between the uh, available habitat, available area, and the uh, species diversity and rate of extinction. And this leads to the theory of island biography, biogeography. It says that on an average, if we lose 90% of habit, which will cause an extinction of 50% of species. So 90% of habitat loss leads to the extinction of 50% of species living in that habitat. And finally, we have mathematical models for estimating the rate of extinction. Mathematical models actually compiling data from different sources and data from the fossil and everything to model a system for predicting the rate of extinction. It considers the population size of an organism and availability of habitat, whether it is increasing or decreasing, how we are exploiting everything. Then species interaction. If you are considering one species, what are the predators, what are the prey, and how other species interactions are influencing particular species and genetic factors. So we are considering all these things. We are creating mathematical models to predict the rate of extinction for the past, present, and future. And by these old models, what we found that after this, like life on Earth, the emergence of life on Earth, approximately 5 billion species has lived on this Earth for different duration of time. 5 billion species, different species. Out of this 5 billion, about 99% has got extincted because of the background extinction as well as due to the mass extinction. 99% of all species lived on this earth has gone extincted, and now we have only 1% of them. So that's this model says to us. And if you consider human induced extinction, human population is actually spread all over the globe in every where humans are there, and they are destroying earth biodiversity at an unprecedented and accelerated rates. And because we are consuming huge quantities of resources for food, energy, and everything, for industry and everything, we are consuming huge quantities of resources, and we have creating large ecological footprints. This image show different animals which got extincted in recent times due to human activities. You might have know the dodo or the golden toad. These all of them got extincted in past centuries due to the human activities. And one of the main problem is the cultivation system. We are using land for the cultivation of crops. This graph show the changes in the cultivated area in last 50 years, and it shows that about one quarter of available land, terrestrial land, is used for the cultivation. And because of this cultivation and agriculture, human has changed the ecosystem more rapidly and extensively than ever. So to meet the rapidly growing demands for food, fresh water, timber, fiber, and fuel, we are exploiting the environment. And this resulted in a substantial and largely irreversible loss in diversity of life on Earth. So you can see, if you consider the case of India, almost all the areas has been converted into for agriculture, so that the natural habitat for the many of this species has lost. So eventually, these organisms will go and extinct it. You can clearly see where all this cultivation system has heavily intruded into these habitats. And based on this different estimate, we have found that the background extinction rate is about 0.0001 percentage. But the current extinction rate is 0.01 to 1 percentage. So if without human activities, we are expecting a extinction rate of 0.0001 percentage, but only because of human activities, extinction rate has been increased to 0.01 percentage to 0.1 percentage, which is actually 100 to 1000 times larger than the background rates. And based on the we don't know how much organisms are leaving this earth. We have different approximations. Generally we say we have 10 million organisms, and some estimates say we have 100 million organisms. Based on this estimate, if we have 5 million organisms, every year we are losing 5,000 organisms due to this extinction. If we have 14 million organisms, about 14,000 are getting extincted every year. Likewise, every year. The other sad situation is like that the human activities are increasing and we are changing the environment so dramatically. So the extinction rate may increase from this 0.01 to 1 percentage to the 1 percentage. So if the extinction rates has increased, instead of extinction of 5,000 species a year, it may lead to the extinction of 5,000 species per year. So situation is very alarming, and we are expecting heavy loss of biodiversity in coming 50 to 100 years, even if we are taking many steps to reduce biodiversity, to protect biodiversity, because the changes has been already occurred. The population growth, we are expecting a huge population growth around the world, and when the population is growing, the resource for per person utilization is also increasing. So the in order to get enough resources for the human population, we will exploit the environment. And it also leads to the climate change, mostly the global warming, which affecting the many habitat and survival of many different types of species. And another reason of expecting heavy loss of biodiversity is the extinction rates are very high in biodiversity hotspots. Some areas has very large rate of extinction, and right now we think we are in a speciation crisis. In natural conditions or the non-human affected scenario, what happens is like uh, there are extinction and there is also speciation. New species emerges to compensate for the extinction, and sometimes the population, and or most of the times the rate of speciation is way much higher than the rate of extinction, so the biodiversity actually increases. But right now what happens is like that because of the human activities, the biodiversity has reduced so much and the extinction rate is so high. Further, the speciation is not happening like it used to happen, because we have eliminated or degrading, fragmenting, or simplifying the biologically diverse environment like tropical rainforest or tropical coral reefs, wetlands, and estuaries. These areas are known for biodiversity, and the speciation used to occur there so frequently. Because of the destruction of these type of areas, what happens is like the speciation rate is also decreased. So because of the reduced speciation rate and increased extinction rate, we are right now at the middle of a speciation crisis. And if you look at the organisms which is in the endangered list, we can see that uh, many organisms are getting extincted because of their characteristics. And famously, Edward Whitson says that the first animal species to go are the big, the slow, the tasty, and those with valuable parts such as tusk or skin. If you take particular examples, like the organisms like blue whale or giant panda, they have low reproductive rates, so that leads to the extinction. Or some of them have this specialized niche, like the blue whale or giant panda, or narrow distribution. Maybe some of them feed at the very high trophic level, like Bengal tiger, or the fish that migratory pattern, some of the turtles, or some of them are so rare, or maybe commercially valuable, like the elephant, tusk of an elephant, or like some of them need large territories, like the panther. So these organisms are at the edge of extinction. Because of their specialized characteristics, they may get extincted fastly. Most of these organisms are keystone species. Loss of this organism will lead to the loss of biodiversity in a large scale. I would like to tell a story about this extinction, especially this bird. It is called the passenger pigeon. This bird has some characteristics, like you can see in this figure. They used to fly in huge groups, basically the gigantic groups. They used to fly as a huge group. In 1813, one of the bird expert, John James Upton, he reported a single huge group of these passenger pigeons. And as per his report, it took 3 days, 3 full days to fly past him. This huge group took 3 full days to fly past him, and it was so dense, and it actually darkened the sky. So can you imagine how many number of birds were there to take 3 days to fly past a single person? So it was so huge. In this image also you can see these are coming from in large numbers. But the thing is that these birds are edible, and its feathers are used to make pillows. Its bones was extensively used in those days for making fertilizers. So it's actually a commercially valuable bird. So what happens is people used to hunt. The commercial hunting was there. Along with, there was a huge deforestation due to the industrialization process. So it has lost the habitat. And the John James has reported the huge gigantic group in 1813, after about 87 years, 1900. What happens is like this bird got extincted. So that was so dramatic. A huge group, like it would take 3 days to fly past a single place, has extincted in 87 years. So that's what rate we are affecting uh, the extinction. And there are different causes of extinction, and major causes. I am just listing the major causes of extinction. The most important factor is habitat reduction and modification, due to the deforestation, due to the conversion into a agricultural land, due to the global changes in climate, and due to everything. There is a reduction in the habitat of organism, which eventually leads to the extinction of organism. And another reason is also population size. If a population size is reduced too small, genetic drift and things like that can happen and leads to the extinction of an organism. Another is overexploitation for the economic benefits. People used to exploit, like the story of this passenger pigeon or the elephant or animals like that, the giant panda. The overexploitation is one major reason for extinction. Finally, it may be due to the species introduction. New species may be get introduced into the area or habitat, so that the competitions and everything leads to the extinction of the organism. So that's all for this video. Thank you so much for listening.